Hello everyone, welcome back to my YouTube channel. In this video, I want to continue to solve the next three questions, which is question number 10 until question number 12 from EDU Physics 2019 first session. You can check link on the description box below if you want to watch the solution for the other problem on this paper, or check my EDU playlist to find out another paper. Okay, let's start from question number 10. In this question, we have a sinusoidal wave with a frequency of 0.5 Hertz. So I have a wave with a frequency 0.5 Hertz that is propagating in the negative direction of an x-axis. You can see from this diagram the direction of the propagation is to the left. The figure below is a graph representing the relationship between the displacement of the medium y and the position x at time t is equal to 0 second. So this graph represents the position when t is equals to 0. And then from 1 until 4, choose the graph that best represent the relationship between y and x at time t equals to 3.5 seconds. So I want to know 3.5 seconds later, the diagram or the graph becomes which one? We have number 1 until number 4. Okay. First of all, I have frequency here. The frequency is 0.5 Hertz. As we know, period is equals to 1 over frequency. Since I already know the frequency, which is 1 over 2 or 0.5, so the period is 1 divided by 0.5, it becomes 2 seconds. This is the period of this wave. You have to remember the definition of period. The definition of the period is time taken for one complete wave. Time taken for one complete wave. So, if I have one point, let's say this point, I assume this is A. 2 seconds later, A will move to this position because this is one full wavelength. This is one wave. So 2 seconds later, point A will move into the new position, which is here. That is the meaning of period. After we know the definition of the period, so I will express 3.5 seconds later in terms of period. As you can see, 3.5 seconds, if I divide it by 2, which is our period, and then I times it by t, which is also our period, so basically we can cancel out these two things and we do not change anything. 3 over 5 divided by 2, I got 3.5, yeah, sorry. 3.5 divided by 2, I got 7 over 4. 3.5 is 7 over 2. Divided by 2, we got 7.4. Period. So 3.5 second is 7 over 4 period. Of course, I can express it as period plus 3 over 4 period. So, if I assume one point, let's say in here, you can assume a random point at a random position. But for me, I will pick this point because this point is easy to spot. If I assume I have this point, which is point A, 1 period later, it will move to here. And then 3/4 period later, it will move into this one. So point A, 7/4 period later, or 1 period plus 3/4 period later, it will move into, this is 1 period, and then add it with 3/4 period, this is half, this is a quarter, then point A will move into here. That means this point will move into this position. So let's say I will draw something like this. This part will move into this part. So if I copy it, I will get this part. So pick the answer that has this part. Of course, you can see my final answer is number 1. Point A will move into this position. So assume this part will move into this part. So my final answer is number 1. You can see number 2, 3, and 4 do not has this feature. So my final answer for question number 10 is number 1. Okay, let's move to number 11. As shown in the figure below, a speaker, this is the speaker, emitting sound of frequency F, is placed near one end of an open tube of length L. This is open tube. The length of this tube is L. A standing wave with n antinodes, including both mouths of the tube, forms in the air column and resonance occur. Here, let us denote as V the speed of sound, and then assume that open end correction is negligible. So, what is the meaning of open end correction? Open end correction is, we can assume that the sound is start from this position, not from the speaker. This small tiny thing is the open end correction. So we can ignore this distance and just assume that the wave or the standing wave is start from this position. The question is, what is F? F is the frequency. So basically I want to find the frequency of the standing wave in terms of speed of wave, length of the tube, and number of antinodes. For this question, we have to remember that open tube, if we have an open tube, standing wave or stationary wave always start with an antinode. I repeat it once again. For an open tube, standing wave or stationary wave always start with an antinode. So this is must be an antinode, and then since the other end is also open, so this other end is also an antinode. So it will start from here and then it will end here or here. For example, let's say I have two antinodes. This is the least antinode that possible. I have two antinodes. The first one is on the left end, and then the second one is on the right hand. So if I have two antinodes, then the wave should be something like this. This is the picture of, or the diagram for the standing or the stationary wave. This is the least antinode that is possible. Two antinode. The diagram is something like this. If you see from this diagram, we have half wavelength. This is half wavelength. This is half wavelength. Half wavelength is equals to L. So for two antinode, we have half wavelength is equals to L. Then wavelength is equals to 2L. After I got the wavelength and I know the speed of wave, which is V, of course we can find frequency. So frequency is equals to, this is the formula of frequency, yeah? Frequency is equals to speed of wave divided by wavelength. If you see from this formula and then I substitute lambda with 2L, then I will get 2V over 2L. This is called as the first harmonic. When there is two antinode, the frequency is this one. And then let's say I have three antinode. If I have three antinode, this is the first one, this is the third one, so there is another antinode in between. There is another antinode in between. So my wave, if I draw it, it should be something like this. This is antinode, this is antinode, this is antinode. It should be something like this. If you see from this diagram, we have one wavelength. This is one wavelength. So if I have three antinode, then in the column with length L, or in the tube of length L, I have one wavelength. The previous one is 1 over 2 wavelength. Now I have one wavelength. I can write it down as 2 over 2. 2 over 2 wavelength is equals to L. That means wavelength is also 2 over 2L. That means the frequency is equals to V over lambda. I got V over this one. If you simplify it, you will get 2V over 2L. 2V over 2L. From these two examples, hopefully you can see the pattern. If I have two antinode, this is the frequency. The frequency is called first harmonic. And then if I add one more antinode in between, so now I have three antinode, this is the frequency. This is called as the second harmonic frequency. If you see from this result, so if I have n antinodes, then the frequency is equals to, you see from this one, yeah, the denominator is 2L, this is also 2L, so the denominator is unchanged. So I can write this as 2L, but the numerator, if I have two antinode, the coefficient of the numerator is 1. If I have three antinode, the coefficient of the numerator is 2. So the coefficient is 1 less than the number of antinodes times phi. So 2 becomes 1, 3 becomes 2. So if I have n antinode, it becomes n minus 1 times phi. Basically, this is the formula of the harmonic frequency of an open tube. So my final answer is n minus 1 times V over 2L, which is number 4. This is the answer for question number 11. Let's proceed to the last question, question number 12. As shown in the figure below, glass plate 2 is tightly adhered to the upper surface of glass plate 1. So if you see from the diagram, glass plate 2 is upper the glass plate 1. The glass plates have different absolute refractive indices. So the refractive index of glass plate 2 and glass plate 1 are different. Light is directed at the interior of glass plate 1. This is the light rays from point A. This is point A on the left side of glass plate 1. And the light's angle of incidence theta is angle of incidence, is gradually decreased. When theta reaches 30 degrees, the light that has entered glass plate 1 is at the critical angle of incidence with respect to the point B on the boundary surface. So when this theta is equals to 30 degree, at point B, there is a critical angle. What is the meaning of critical angle? Critical angle is angle of incidence. Since they tell us the critical angle to point B, so critical angle to point B is the angle of incidence at point B. Let us assume as alpha, that produce angles of refraction equals to 90 degree. That is the meaning of critical angle. So critical angle is an incident angle that produce refractive angle equals to 90 degree. When theta falls below 30 degree, the light is completely reflected at the boundary surface. So when theta less than 30, total internal reflection is occurred. The left side of glass plate 1 is perpendicular to the upper surface. The left side is perpendicular to the upper surface, denoting the upper left vertex as O. OA is equals to 5 and then OB is equals to 12. Of course, AB is 13. This is the hypotenuse of right angle triangle. And then assume that the absolute refractive index of air is equals to 1. Of course, this part is air. The index or the refractive index of air is equals to 1. The question is, what is the absolute refractive index of glass plate 2? So I want to find the index of plate 2. I will assume the refractive index of glass plate 1 is equals to N1. We still do not know N1. And then the refractive index of air, I will write it down as NO is equals to 1. Since we talk about refraction, so I can use Snell's law. So to solve this question, I will use Snell's law. The Snell's law is basically NO times sine theta, so the index times sine of incident angle is equals to N1 sine refractive or refraction angle. So if I apply Snell's law into point A, so I will get NO, which is 1, sine 30 is equals to, we still do not know N1, yeah? We still do not know N1, times sine R. R is the refracted angle. You have to remember, incidence or refraction angle always measured from the normal line. So R is this one. I need to know what is sine R. If you see from this diagram, of course, if this angle is R, and then I will extend it to point B, and then I will have parallel line here. So if this one is R, this is also R. This is alternate angle. And then if you see this triangle, sine R is equals to opposite over hypotenuse. So sine R is equals to 5 over 13. Sine 30 is equals to half is equals to N1 times 5 over 13. Then I get N1 is equals to 13 over 10. This is the index or refractive index of glass plate 1. So I already know that N1 is equals to 13 over 10. Now, let us use Snell's law once again, but we will apply it at point B. So by using Snell's law at point B, I will get N1 sin alpha, the index times sine of the incidence angle, N1 times sine alpha is equals to N2 times refracted angle. The refracted or refraction angle is equals to 90 degree. How do I know it is 90 degree? Because alpha is the critical angle. You have to remember the definition of the critical angle. So N1 times sin alpha is equals to N2 times sine 90. N2 sine 90 degree. Since I already know that alpha is equals to, N1 I mean is equals to 13 over 10 times sine alpha. We still do not know sine alpha, but of course, if you see this right angle triangle, you can find sine alpha. Sine alpha is opposite, the opposite side is 12 over hypotenuse is 13. So sine alpha is 12 over 13 is equals to N2 times sine 90 is of course equals to 1. And then if I cancel out 13, I will get N2 is equals to 12 over 10, which is 1.2. This is my final answer. So my final answer is number 2. This is the solution for question number 12 and also the end of this video. Thank you very much guys for watching this video till the end. I really hope I see you guys on my next video. Thank you and bye-bye.